The final topic for my presentation is on treatment of flood tanks and benches. And I think that this is the most challenging irrigation system to get effective water treatment control. But let's start simple. In a simple system, we have linear flow from a well out through the irrigation line and into the greenhouse and nursery. We can put the filtration system and a chemical treatment sanitizer in there. It can be quite effective. The next most difficult situation is with pond treatment, and the reason is that the organic load can be very high. So here we've got pond water, perhaps being blended in with well water, going through filtration, chemical treatment, and then out to the greenhouse and perhaps being recaptured back into the pond. The key challenge here is that there has to be a very good filtration system and the organic load is going to be higher. The most complex situation is when we have rapid cycling of nutrient solution in tanks. So here, for example, we have a flood floor greenhouse where water is going out with fertilizer, subrrogating crops, coming back through a return filter back into a tank and being reused in other bays. So this rapid cycling means there's very short contact time and there is always some organic load, potential for a pathogen load in our system. I'm going to give you a couple of examples of why this is a challenge. One is we've been testing some ozone systems out in greenhouse operations and taking water samples before and after ozone injection. One of the things that we noticed was that we look at the color of the irrigation solution, which contains fertilizer, before the injection. It has certain color from the iron EDDHA chelate, this orangey color, and after ozone treatment, the irrigation solution is clear. Ozone is used to clarify solutions. It's an oxidizer, very effective, very strong. It will break down not only pesticides, bonsai, for example, but it can also potentially break down fertilizers. Another interesting result was that it's very important when you're treating these tanks that you treat them enough. You can see on the horizontal axis here the hours of tank cycling, and on the vertical axis the bacterial load. And we're seeing numbers both pre-ozone, so that represents what's in the subrogation tank, and post-ozone immediately after the injector. What you can see is that the bacterial counts being sampled from the tank actually increase initially as we start to run the ozone injector, and then we achieve control. What's probably happening is that ozone is mostly having an initial effect in terms of oxygenating the tank and perhaps breaking down some organics, making certain nutrient sources available. So this rapid cycling time that we have in subrogation tanks is quite a challenge for sanitation. You think of chlorine as another alternative for that situation. It also interacts with fertilizer. Now, one of the good things was when we looked at chlorine and we added a fertilizer solution to the chlorine, then only a small amount of our iron chelate, 1%, was actually broken down. So that's a good thing. So the chlorine was not such a strong oxidizer that it was breaking down the iron fertilizer. However, we have some more complex chemistry going on as well, where the chlorine actually interacts, reacts very quickly with the ammonium fertilizer and to a lesser extent urea fertilizer to form chloramines, which are a less effective sanitizer. So for example, when we mixed this 1.7 parts per million of chlorine with our 17,4,17 fertilizer, within 5 seconds the active ingredient level went down from 1.7 parts per million down to 0.11 parts per million of chlorine. So much of that chlorine was being deactivated by the fertilizer. So we need to know more on sanitizing flood tanks. Chlorine's not ideal. It can be used, but the active ingredient concentration needs to be increased because of this chloramine formation. We don't know much about chloramines and phytotoxicity and sanitation for plant pathogens. More research is needed there. Ozone can be effective. It's certainly a strong oxidizer, but it's got challenges with micronutrients and it needs to have enough contact time. So currently we're doing some research work at looking at some other sanitizers for this situation. So in summary, there's no silver bullet when it comes to water treatment. For every complex problem, there's a simple solution, and the saying goes, it's always wrong. And I think it's important to consider as one final thought that the irrigation system in our greenhouses is part of an overall ecosystem. There are microbes living in that water, there are beneficials, there are don't cares, as well as the bad guys, the pathogens. And that's true also out in the growing media and on the plant surfaces. So the irrigation system is an ecosystem. And really the idea that we're just going to put a bunch of toxins into our water and solve all of our disease management issues is certainly not the case. So what we want to do then is we want to have an integrated solution. You want to work with advisors both from universities as well as from industry to design systems that include filtration as well as sanitation. They deal with whatever problems you're having, whether it's a physical, biological, or nutritional problem with your water quality, and come up with an integrated overall solution that meets your goals. With that, I'm going to finish, and I'll open up the line for any questions.